So guys, today we're going to talk about exponential functions. Now, this was introduced to y'all a little bit because our geometric sequences they grow exponentially, okay? They have an exponential relationship. So we just finished doing our geometric sequences. So now, guys, we're going to talk specifically about exponential functions. And so it is a function in this form right here. F of x equals a times b to the x power. So if you have a highlighter, now's a good time to go ahead and highlight that. And guys, your a cannot be 0 and your b cannot be 1. Okay? And really, part of the reason we call it an exponential function is because our variable, or the x, is in the exponent. Interesting. So the variable is in the exponent. So guys, the thing that is changing is in our exponent. So the relationship between our numbers is exponential. All right? Now, some important things to make sure that we identify in our graph here today is our a value, this initial a value. You can't find them? Okay. The initial a value is our y-intercept. Okay, so this is what they look like. Anybody else struggling to find that note? Alg Hon Unit 5, sequences and exponentials. If you need it, though, I'm showing you that right here. Okay? So we got these guys right here. Great. And if you need it, okay? So this a right here is your y-intercept, and the starting value is 0a, okay? So this is really important. It's your starting value. It's kind of where you begin, okay? The b, this number right here, is your growth or your decay factor, okay? So this is the growth or decay factor. This tells us how much we are growing or how much we're decaying. Now, guys, growth happens when your b is greater than 1. Decay happens when your b is between 0 and 1. Great job. Okay? So decay happens when your b is between 0 and 1. Now, guys, in a real-world graphing situation, your b will never be negative, okay? Because then it would not graph, because remember, when we were doing geometric sequences, if that ratio was negative, it would bounce back and forth between positive, negative, positive, negative, positive, negative, positive, negative. So you would never be able to graph it. So your b is not negative, okay, in this circumstance, okay? Now your horizontal asymptote, that's kind of a funny word. Sound like you're saying a bad word, but it's basically a horizontal line. It is a boundary line that your graph approaches, and it will normally not cross it, okay? In our exponential functions, it will not cross it. There will be times when you get into some Algebra 2 stuff where you will cross some boundary lines, but in Algebra 1, we will not cross our horizontal asymptote. It's basically you can get really close, but it doesn't touch, okay? And guys, this is a horizontal line, so it's going to be written like a Hoy line. Our slope will be 0, and it's usually y is equal to 0, okay? That is usually your horizontal asymptote, all right? There are some special cases where your horizontal asymptote is not y equal to 0, and I will show you when that happens. It's a very clear thing that happens when it's not y equals 0, all right? So, another way, I just want you guys to see this, another way that you can write this is you can, sometimes, guys, people write it as y equals, like your b is inside the parentheses. That looks a whole lot like our geometric sequences there. Your b is often, guys, it's going to be the same thing as that ratio, okay, that growth or decay factor, all right? And so sometimes you see it with the parentheses, sometimes you see it without, all right, guys? I just want to prepare you for that. So this one right here, let's graph this function, okay? So before we get going too far, everyone is going to need a calculator today because we are going to be using a calculator to look up all the tables. So can I get everybody a calculator? Does anybody need one? Anybody else? Okay. That's wonderful. I've got calculators. That's wonderful. All right. So, thank you. Alright guys, so everyone is going to need a calculator today. And guys, we are going to graph this function. So before we actually type it in the calculator, I want us to think about a couple little things. Okay? What is my A value? What's the number on the, like the B is the one that's being raised to our exponent. So this right here, the 4 is my B value. Okay? What is my A value? What's the number on the outside there? Is there anything on the outside? No, it's just 1. Okay? So it's kind of like it's 1 times 4 to the x. Does that make sense, guys? So your A value is just 1. So what this is telling us is that my y-intercept should be 0, 1. And my B, that's my growth factor, or my decay factor. What is this? Is this going to be growth or decay in this case? This is going to be growth because it's greater than 1. It's greater than 1, it's growth. So guys, I'm going to go over here. I'm going to write growth. I'm going to write my y-intercept as 0, 1. Here we go. And now, so we kind of know these things. And then now let's see what this actually looks like. So I want you guys to take your calculators. Okay, go to your y equals. If there's anything in your graph, clear that out. And I want you guys to type in 4 to the x power. So you go to your y equals, right up here, and then you want to type in 4 to the x power. Let's just see what this graph looks like. Okay? This right here is called exponential growth. Do you see how it starts off like da-da-da-da-da-da-da, and then it grows super rapidly? Do y'all see that? So it starts off kind of tapered, and then it grows super rapidly. Does anyone have a hard time typing in that 4 to the x into their calculator? Yeah? Okay, so what do we need help with? Talk to your neighbors, make sure that you guys can type it in. This is what it should look like. Yeah, now hit graph. Hit graph. Yeah, so you can hit graph, and this is what you'll see. You hit graph, this is what you should see. Okay? Now, what I want to do is, guys, I want to actually see what my values are. So I'm going to go to my table. How do you get your table? Is you do second graph, because table is in those little blue words right above graph, so you have to hit second first. We have all these table values. Well, I'm going to fill in this table over here on the left, and we have -2.0625. We have -1.25, 0, 1, 1, 4, and 216. So, guys, you do second graph to get to your table. So, guys, anything that's blue on your calculator, if you hit second first, it activates it. Does that make sense? So if you see second, if you want to insert something, you do second, and then you hit that little delete button, and it inserts stuff. It's kind of cool. Okay, if you want to quit out of a page, you go second mode, and you quit out of the page. You go back to the home screen. So guys, I just got these table values, and I copied them down right here. Now let's try to graph them. First of all, you'll notice, is that my y-intercept, 0, 1? Yeah, we already got that from the equation, right? So now let's actually graph these little points. So -2, -0.0625. Wow, it's like super tiny. -1.25, so it's a little bit bigger. 0, 1, 1, 4, 216. Good night. So that's going to be like way off the page, right? So if we drew our sample graph right here, what you will notice is this is kind of what it's going to look like. Do you guys feel good about that? Okay. Now here's the thing, with exponential graphs, it's not going to be the prettiest thing in the world. Okay? But what's important is to dot, if you graph a few of those points along with that table, then I will see that you knew what you were supposed to be graphing. Does that make sense, y'all? Now what I want you guys to notice is as I go in the negative direction, do I ever actually equal 0 here? Does my y value ever equal to 0? No. It's super, super, super tiny. We have all this scientific notation going on. But it never actually equals 0. If you go up high enough, I don't know if it actually says 0. But see, it's like super, super tiny to the negative 10 to the 21st power. That's crazy. Okay? So guys, my line never actually hits 0. So that means that this horizontal asymptote is going to be right here at 0. So your horizontal asymptote is going to be equal to 0. And guys, I know it's a little deceiving because on the calculator it looks like it hits 0, doesn't it? It looks like it hits it. It's just because there's such tiny numbers, it's hard for us to see. If I actually zoom in, if I go over here and I pick a spot to zoom in on, I have to do it a few times. Okay. Ooh, look. I'm going to keep going. Zoom in. Look at that. Do you see how it doesn't actually hit the line? It's really, 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 really close. But it doesn't actually hit the line. But if I go back to my standard zoom here, it sure looks like that was hitting the line. But if you actually zoomed in on it, like super, super magnification, it doesn't actually hit the line, okay? So your horizontal asymptote in this case is y equals 0. Now my domain, what is my leftmost boundary here? Now we're thinking the blue line. What is the domain here? What is my leftmost? Negative infinity. Okay? What's the rightmost? This arrow means it's going to go keep going forever and ever and ever in the positive infinity direction. So guys, my domain is from negative infinity to positive infinity. But guys, I want us to start moving away from this. Instead of saying negative infinity to positive infinity, I want us to say that all real numbers. Do you guys remember that little double R there? That means all real numbers. Okay? So instead of saying negative infinity to positive infinity, that's not wrong. You just won't see it as much in that way. You're going to kind of see the infinity start to be dropped. Okay? And my range, these are all my y values. Remember, domain is x and range is y. So we're going to start at the bottom. What's my lowest y value? Does it ever touch 0? No. So what I'm going to say is that because it's not equal to 0, it gets really, really, really close, but it doesn't touch it. What's my highest y value? Positive infinity. But guys, once again, I want us to get to the point where we're dropping our little infinities here so we can say y is just greater than 0. Okay? So your y is going to be bigger than your 0. So in this case, guys, all of my y values are bigger than 0. Does that make sense? There's nothing that's graphed underneath the 0 line. So there's nothing that is graphed when your y is negative. Also, one thing I want you guys to notice is your horizontal asymptote and your range are going to be very closely connected to one another, right? Because your horizontal asymptote kind of gives you that boundary line. So that horizontal asymptote will tell you where your kind of stopping point is. Everything's either going to be bigger than that or smaller than that, okay? So you have to look and use your senses here. So this one is growth because my b was greater than 4, or greater than 1. Okay? Now let's take a look at number 2. We're going to do one more example here. Okay? So let's look at this. 1/2 x. So what is my a value again? My a is equal to just 1. Okay? Which means that my y-intercept is going to be 0, 1. Alright? So we have a y-intercept of 0, 1. Do you guys feel good about that? Then my b value. What is my b value in this case? 1/2. Y'all see that? That's what is being raised to the exponential power. So this is my b value. And so is this greater than 1 or less than 1? Is 1/2 greater than 1 or less than 1, y'all? Less than. So this right here would represent decay because we are less than 1. So we are looking at decay for this problem. Okay? Now, let's see what this actually looks like in our calculators here. So you can type this one of two ways, okay? If you want to type it as a fraction, or if you want to type it not as a like fancy fraction, you can do that, and you can just say y equals parentheses 1/2 x, okay? Now here's the thing, if you do this, you have to include the whole fraction inside that parentheses, okay? If you do this, you're going to have to put that fraction inside the parentheses, all right? And if we graph it, this is what it looks like, okay? So this is a decay function. Now, here's the other thing. You also can type it in as a fancy fraction, okay? And you don't necessarily need the parentheses when you type it in as a fancy fraction, okay? Because it does it that way. If I hit graph again, look at that. It's literally just going to graph the line right on top of the other one, okay? So these are the exact same line, but they'll be written either as decimals or fractions in the table, okay? So when I go to my table value, I go second graph. Okay, so my -2, so because they're literally the exact same line, we have them both ways, it's going to appear this way in our table. So check it out. -2, my value is 4, right? And then -1, my value is 2. 0, my value is 1, which is what we expected. We expected our y-intercept to be 1. Okay? And then my value for 1, you could either write it as 1/2 or you could write it as 0.5. You can write it as a decimal or you can write it as a fraction, okay? And then for 1/4, it's either for 2, it's either 1/4 or 0.25. You can write it either way. All right, guys? It does not matter to me. I would pick one, though, and stick to it, okay? Don't do both. I'm writing both to show you that you can do both, but pick one, okay? If you're a fraction person, write it as a fraction. If you're a decimal person, write it as a decimal, okay? Then we're going to go here. Let's actually graph this. -2, 4. -1, 2. 0, 1. 1, 1/2. 2, 1/4. And then, guys, what you will notice is as you go, it gets smaller and smaller and smaller and smaller. Does it ever touch 0? No, it never touches 0. Okay, guys? But it just gets tinier and tinier and tinier and tinier. Okay, guys? So it gets smaller and smaller either as a fraction or a decimal. So we're going to kind of do this. Draw my little line here. It never actually touches that x-axis, okay? Or yeah, it never touches that x-axis. So if that's the case, what is my horizontal asymptote, y'all? What will it never cross? 0. So my horizontal asymptote, again, is just y equals 0. Okay? Now today we notice, okay, what is my domain? Well, to the left and to the right, does it go on forever in infinity direction? Yes. So this one is going to be all real numbers. My range, well guys, remember it's connected pretty deeply to that horizontal asymptote. So let me ask you this question. Are all of my y values greater than 0 or less than 0? Are they bigger than 0 or are they smaller than 0? Bigger, right? Everything is above the 0 line. Does that make sense, guys? So it's going to be y is greater than 0. You could say from 0 is less than y, which is less than infinity. You could also say it just like this, or you can just say y is greater than 0. All right? Y'all feel okay with that? Okay. Let's look at our next couple graphs here, okay? Now, I'm actually not going to do this one fully with you guys. I'm just going to look. I want you guys to recognize something. Again, this is just, it's a lot of repetition here. My a value is 1, which means that my y-intercept is 0, 1. Okay? My b value is 3/2. Well, guys, is 3/2 greater than 1 or less than 1? It's a fraction. It's greater than 1. So, guys, even though this is a fraction, this still represents growth. Okay? So, even though this one is a fraction, it still represents growth because it's greater than 1. Does that make sense? Now, when I actually type this guy in, if I typed in, let's see here, alpha y equals 3/2 raised up to the x power, what you guys see is it does grow. Does it grow as rapidly as the 4x? No, but it's still considered growth because it's growing. It's getting bigger and bigger and bigger and bigger positively. Does that make sense? Growth always goes up at the, or it always is increasing or decreasing super, super rapidly at the end, okay? So growth is something that can be that positive, and then we're going to look at what happens when it's negative here in just a second, okay? So, guys, this one, I'm not going to go through everything with y'all. I can put it up here. The y-intercept was 0, 1. The horizontal asymptote, again, is y equals 0. My domain is all real numbers, and my y is greater than 0. So if we actually graph this, you would be able to see the different growth that happened here, okay? So, and my line would look kind of like this, okay? This is not perfect. I did not graph all the points. This would not get me all the points if I did this on my test, because I didn't graph all my points, did I? Okay? So this would not get me all the points, but I just want to give you guys a quick little sketch. Alright, guys? Y'all feel good about that? If I really wanted to get the actual points, I would go to my table and fill in my table here. Okay? Now, let's take a look at number 4 here, okay? Number 4. Our growth right here, let's see if it's growth or decay. So first of all, what is my A value? Ooh, now we actually have an A value, don't we? It's -2. So that means my y-intercept is going to be 0, -2. Y'all feel good about that? Okay. What is my B value? 3/2. Okay. Is that growth or is that decay? That is going to be growth because our number is greater than 1. So we know that this is growth, and we know that our y-intercept is 0, -2. Okay? Now, one thing I want to show you that's a little bit weird about this is that if we have this function here where we have -2, 3/2 raised to the x power, guys, that negative doesn't just put my y-intercept at -2, it also reflects my graph. It kind of like, whoop. Now, it's not growing in the positive direction. What is it growing in? The negative direction. But this is still considered growth because if you look at the end of your graph, it's getting, the numbers, the absolute value of those numbers are getting bigger and bigger and bigger and bigger. Does that make sense? It's not tapering off. It's getting larger and larger and larger and larger. Okay? So this right here is still considered exponential growth. Even though it's going down, it's growth because it's a negative growth. Does that make sense? That negative in front of it flips it. Alright? So now let's go to our table. Let's fill in our values here. So mine are filled in as fractions. If you want to do them as decimals, that's A-OK. 8/9, -4/3, -2, -3, -9/2. So guys, remember that -2 is what we were hoping for our y-intercept, so that's good news. If you wanted to write this as decimals, it might be a little bit easier to graph, because that's -0.88, -1.33, -2, -3, -4.5, and so on. So if you wanted to write these as decimals, that might be a little bit easier to graph, but you don't have to. Okay? So negative 2 is negative 0.8, so that's just below the 1. 1.33, okay. 0, 2, 1, negative 3, 2, negative 4.5. I believe 3 is what? Negative 6.75, so I might just do that real quick. Okay, so this right here is what this negative exponential growth function looks like. Okay, so what is my horizontal asymptote? What does it get really, really close to but never touches? Yeah, 0. So my horizontal asymptote is still y equals 0. What is my domain? What are all of my x values? It's all real numbers. It goes forever in the left, and it goes forever, this down means forever in the right. So this one is all real numbers. My range, okay, remember, it's connected to that horizontal asymptote. Are all of my values bigger than 0, or all of my values smaller than 0? Smaller. The graph is below the line, so this time it's y is less than 0. This is new, okay? Now that it's below the line, my range is y is less than 0, okay? And does anyone have any questions for this? This negative growth can get kind of confusing, okay? So you can have regular growth, you can have negative growth. It gets a little bit confusing when you see the different things, all right? So what I always do when I'm thinking, is it growth or decay? Look at your b. Look at that factor. If that's bigger than 1, it's growth. If it's less than 1, it's decay. So it's super important to look at that b, that rate of growth or decay factor. All right, let's look at number 5 here. So this is kind of our special case, okay? So what is my a value in this case? 3. So we would assume that our y-intercept would be up here at 0, 3, right? Okay. My b value is 2/3. So is that going to be growth or decay? That is going to be decay. All right? Because it's less than 1. So we know it's going down. Now, we have something new, don't we? This -4. Okay, guys, this value right here, this -4 at the end, means that we shift the entire function down 4 units. Okay? So we're going to take everything and shift it down. Does that, so it's like we have our 3 2/3 the x, and we're just going to move it down 4 units. So my new y-intercept would not be up here at 3. We're going to shift it down. It's going to go doing 2. It's going to be down here at -1. Do y'all see that? So my y-intercept is actually 0, -1. Because 3 minus 4 is -1. Do y'all feel good about that? This is the only time things get shifted. What do you think is also going to happen to your horizontal asymptote? It's not going to be y equals 0. If we shift it down 4, it's going to be y equals -4 because it got shifted down. Does that make sense, y'all? So that -4 means that we shift, that is going to affect your y-intercept and your horizontal asymptote. Now let's see if that's actually true when we go ahead and plug all this stuff in here. So I'm going to say 3 alpha y equals 2/3 raised up to the x power -4. So when I go to my graph, this is what it's going to look like. Remember, it's exponential decay, but it's like everything just got bloop, shifted down 4 units. So when I go to my table here, is this actually true? Ah, man. Okay, I'm going to change this so I am not in the, I want decimals, okay? So here we go. So -2 is 2.75. Negative 1 is 0.5. 0 is negative 1. Is that what we got after we shifted it down? Yes, it is. Does that make sense, guys? So it's going to shift it down some. All right? And then we have 1. And that's going to be what? 1, negative 2. Is that right? And then 2, negative 2.667. I'm just going to add a few more. 3, negative 3.114. 4, negative 3.407. Okay, and what do you guys notice about this? Does it ever actually touch 4 there? No. And actually, because the calculator just can't handle, it does actually start to say the number 4 on the table, but when you actually click on the number, look what it actually is. Negative 3.9995. 990284536. So they actually tell you what it is. It's not actually 4. It's just really, 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 really close to negative 4. So that shows us that that horizontal asymptote is actually equal to 4. So if we graph these lines right here, so negative 2, 2.75, negative 1 is 0.5, 0, 1, 1, negative 2, 2, negative 2.67. There we go. All right. So we kind of see how it's going to taper off, okay? So this right here is a great example of exponential decay. Do y'all see that? So this right here is decay because my 2/3 is less than 1. What is my domain? Oh, we didn't draw. Sorry, y'all. I'm a little hot mess today. We didn't draw these. Do y'all feel good about that? Now, what is my domain here? It is all real numbers. And my range, guys, remember, it's deeply connected to that horizontal asymptote. So are my values greater than negative 4 or are my values less than negative 4? They're bigger. It's everything bigger. So y is greater than negative 4. All right? Do y'all feel pretty good about that? About graphing those and recognizing those key features of the exponential functions? Y'all feel pretty good?